Now, how to find the roots is the biggest question which comes followed from the continued session. So how to find the roots of the quadratic equation in its general form or the standard form, ax square plus bx plus c equal to 0 with a not equal to 0. So how do I find the roots of this standard form of quadratic equation? So let's see through the derivation. Say, let alpha be one of the root. Let alpha be. Now that this quadratic equation has two roots because the highest power is 2, so we need to identify two roots which can be possible through the given quadratic equation. So what I do is I'll take one of the root as alpha, then I would like to find what exactly would be alpha in its derived formula. So let alpha be the root of the given quadratic equation ax square plus bx plus c equal to 0. So in this case, because alpha is the root of the quadratic equation, that alpha must satisfy the given quadratic equation when substituted in place of x. Therefore, x equal to alpha implies this quadratic equation reduces to a alpha square plus b alpha plus c equal to 0 is how this equation reduces, because x equal to alpha is the root of the given quadratic equation. Now, I try to simplify this by taking a alpha square. I would like to take a common out here so that I get alpha square plus b by a of alpha plus c by a equal to 0. So I'm taking a common out of the entire equation, so that when I take a common out of alpha square, it's only alpha square remaining inside. But when I take a common out of it, then I have a in the denominator. Because I don't have a term, this is how I take common, so that when I multiply, the a gets cancelled and I retain back b alpha in its original form. Similarly, when I just want to have a taken out of c, it can be taken out by c by a times, is how I remove a out of the brackets. Now that implies alpha square plus b by a alpha plus c by a is equal to 0 by a, which is 0. Now since a is not equal to 0, only then I can divide this on the right hand side. But if a is equal to 0, I cannot restrict in taking this. My restriction is that I cannot take a to the right and divide by, because denominator being 0 is not defined. Simply because if a equal to 0, then it gives me the form 0 by 0 when I go to the right, which is an indeterminate, or an undefined value. Therefore, I can take this to the right strictly because a is not equal to 0, and therefore I get this to be 0. Then finally my expression on the left hand side is alpha square plus b by a alpha plus c by a equal to 0 is finally what is reduced from the previous equation. Now I would like to make this a perfect square or a complete square form. So therefore I just bring it in the form a square plus 2ab plus b square, which gives me a plus b whole square concept. Therefore let's try to see how we can convert this into a square formula, a plus b whole square. So alpha square 2 times of b by 2a into alpha plus c by a is equal to 0. Therefore a square plus 2ab plus, adding and subtracting this, gives me the perfect square form, because I have a square plus 2ab plus b square is not available. So I add and subtract this so that this becomes a perfect square. A square plus 2ab plus b square, which is a plus b whole square. So therefore this gives me a plus b whole square, and this would be minus b square by 4a square plus c by a equal to 0. And this on further simplification gives me alpha plus b by 2a whole square plus 4a square being the LCM, and then gives me 0. The LCM of this and this gives me b square minus 4ac by 4a square equal to 0. Therefore, this on further simplification gives me alpha plus b by 2a whole square equals, this taken on the right gives me b square minus 4ac by 4a square taken on the right hand side of the equation. Now this being a square, when I remove the square, it reduces to root on the right hand side, because when x square is y, that implies x would be plus or minus root y, is how I understand the concept. Therefore, when x square is y, x would be plus or minus root y. So x square equal to y gives me x equals plus or minus root of b square minus 4ac by 4a square. So this is strictly using this formula out here, taken out here. Therefore, this would be further simplified, gives me alpha plus b by 2a is plus or minus root of b square minus 4ac, but 4a square under square root of 4 is 2, and root of a square is a. Therefore, this reduces out of the root as 2a. Then my alpha is, I take this to the right so that I get minus b by 2a plus or minus root of b square minus 4ac by 2a. So taking 2a common in the LCM, this reduces to alpha equal to, gives me alpha equal to minus b plus or minus root of b square minus 4ac by 2a. This is how we derive for the root. So this is said to be the root of the given quadratic equation. So whenever I have a quadratic equation in general form with a not equal to 0, then the two roots which we identify for this would be one with plus minus b plus root of b square minus 4ac by 2a is one root, and minus b minus root of b square minus 4ac by 2a is the other root of the given quadratic equation. So continued from, we have that for the given quadratic equation ax square plus bx plus c equal to 0 with a not equal to 0, I get two roots which are given by the formula by 2a. So there are two roots, one given by plus and the other given by minus. Therefore, when I take distinctly, one of the root is minus b plus root of b square minus 4ac by 2a, and the other root is minus b minus root b square minus 4ac by 2a. Usually these are the two roots which gives me the roots or the zeros of the given quadratic equation. So let's see with an example how we can find the roots using the formula. And this is said to be the formula for finding the roots of the given quadratic expression. Say I take an example. I wanted to find the roots or the zeros of the given quadratic equation x square minus 5x plus 6 equal to 0. Now when I see the left hand side, the quadratic expression here is x square minus 5x plus 6. Therefore, identifying a to be the coefficient of x square, which is 1 times of x square. Therefore, my coefficient of x square, which is a, is 1. Then the coefficient of x, which is b, is negative 5, because I identify this to be a, b, and c. So b is minus 5, and the constant term, which is independent of x, is identified to be 6. So once we identify the values of a, b, and c, we substitute in the formula so that we get the roots of the given quadratic equation. So substituting in this formula, minus b plus or minus root of b square minus 4ac by 2a, I get this to be minus b plus or minus root of b squared minus 4ac by 2a is how I substitute and simplify. Now this, on further simplification, gives me negative times of negative 5, which is 5 plus or minus root of minus 5 whole square, which is 25 minus 24 by 2 times of 1, which is 2. This on simplification gives 5 plus or minus root 1 by 2, which is nothing but 5 plus or minus 1 by 2, because root 1 is 1. Therefore, I have two roots here. One is 5 plus 1 by 2 and 5 minus 1 by 2, which gives me 6 by 2, which is 3. And this further gives me 4 by 2, which is equal to 2. Therefore, I identify x equal to 2 and x equal to 3 are the roots of the given quadratic equation. So x equal to 2 and x equal to 3 are the roots for the given quadratic equation x square minus 5x plus 6 equal to 0 is how I derive the roots using the formula, the basic formula. So now that we have discussed about the roots of quadratic equation, and we have always identified that there are two roots for the given any quadratic equation given. Now let's see how one repeated root can exist for a quadratic equation, as we have already discussed in the previous session. So let's see one specific example. X square is equal to 0. So I have this quadratic equation where let's see how we can find the roots using the formula. So in this case, I identify a to be 1 and b to be negative 14 and c is 49 as taken in this form. This is a, this is b, and this is c. So let's substitute this in the formula and find the roots. So to find the roots, I have the formula x equal to minus b plus or minus root of b square minus 4ac by 2a, which on further simplification gives me minus b plus or minus root of b square minus 4ac by 2a, which on further simplification gives minus of minus is plus root of 14 square is 196 or by 2. So this gives me equal, so that when on cancellation gives me root 0 is 0. Therefore, I get this to be 14 plus or minus root 0 by 2, which on further simplification gives me 0 by 2. Therefore, I get two roots out here. So one given by 14 plus 0 by 2 and 14 minus 0 by 2, and thus this gives me 14 by 2, which is 7, and this gives 14 by 2, which is 7. So I get two roots out here, but I identify here that both the roots are same, which is called one repeated root. So this is the case where I have x is equal to 7, 7, where these two are repeated twice. Therefore, in this case of an example where you get repeated roots, the given quadratic equation x squared minus 14x plus 49 is said to have is the repeated root of x squared minus 14x plus 49 equal to 0 is how I understand the repeated root concept. So there are two types of roots. One is the two roots of quadratic equation might be distinct as seen in the previous example, but the two roots might be equal, called the repeated root of the given quadratic equation. So the roots can be equal or may not be equal. If equal, they are called repeated roots. If not equal, they are called distinct roots or zeros. or solution of the given quadratic equation. Discriminant is the next definition what we're going to see in the properties of quadratic equations. This is an extended property. Let's see what a discriminant is. The expression b square minus 4ac is called the discriminant of the given quadratic equation, and it is generally denoted with delta. This is the notation for discriminant, where delta is b square minus 4ac is called the discriminant of the quadratic equation. Delta equal to b square minus 4ac is called the discriminant of the quadratic equation equal to 0. So this is how we identify the discriminant of the quadratic equation. This not equal to 0 with a not equal to 0 is how I identify the discriminant, and denoted with delta. This is read as delta. So let's take an example to find the discriminant of a quadratic equation. So when I take an example quadratic equation, 4x squared minus 3x plus 11 equal to 0, then minus 11 equal to 0, then I would like to find the discriminant of this quadratic equation. So before we find the discriminant, I identify the values of a, b and c from the given quadratic equation, where a is clearly the coefficient of x squared, and this is b and this is c. So a is 4, b is minus 3 and c is minus 11 are the three constants identified from the given quadratic equation. Now we know that the discriminant denoted by delta is given by the formula b squared minus 4ac. Therefore, when I substitute b as negative 3 squared minus 4 times of a times of c, on further simplification gives me the value of delta. So that this gives me 9 minus of minus plus 4 4 16 176, and this gives me the value as 185. Therefore, the discriminant of this given quadratic equation is identified as delta equal to root 185. Root of this as 185, not the root. So delta is 185 for the given quadratic equation. So next, let's connect the discriminant with the roots, expressing the roots in delta form. Or discriminant form. So delta or discriminant form, we see how the given roots can be expressed in discriminant form. Say I have the quadratic equation ax squared plus bx plus c equal to 0 and a not equal to 0, then we all know that delta is b squared minus 4ac. So using this concept, let's see how the roots can be simplified, reduced to delta form. So we all know that the roots of the given quadratic equation in general form is given by the formula minus b plus or minus root of b squared minus 4ac by 2a. That implies my x with b squared minus 4ac being equal to delta can be replaced inside the root with delta, is how I convert the given roots into delta form. So this would be minus b plus or minus root of delta by 2a. So I substitute the value of delta inside the root and I get this in the roots in delta form. One root being with plus and one root being with minus is how I get the roots in delta form. So when we substitute the delta by simplifying, we get the answer directly for the root. Now next, what is the significance of delta? The discriminant. What is the use of delta the purpose of inventing delta to be b square minus 4ac is very important in quadratic equation inventions. So significance of delta is clearly identified here because delta is clearly identified inside the root. So if delta is positive, the root is defined for a positive number. If delta is negative, then it is not defined for root of a negative number. It becomes complex. Therefore, delta decides the nature of the roots. So delta decides the nature of roots. So the nature of roots can be easily identified through its presence inside the root. So delta, firstly, I identify that if delta is greater than 0, that implies the root is defined for a value which is positive or greater than 0. That implies roots are real and distinct. Real and distinct. They cannot be imaginary numbers. And next, when delta is equal to 0, the whole of this term vanishes, and therefore the whole of plus or minus 0 gets vanished, and therefore I get only one root, which is a repeated root. As I can see clearly here, if delta is substituted with 0, then this becomes minus b plus or minus 0, then it reduces only to one unique term. That implies roots are real and equal. So in this case, I get two equal roots or one repeated root, which is nothing but x equal to minus b by 2a. I get the root to be minus b by 2a as the root when delta equal to 0. When delta is greater than 0, I get two roots which are real and distinct. When equal to 0, I get only one root which is repeated. Thirdly, when delta is less than 0, root of a negative number is not defined on real plane. Therefore, root of a negative number is strictly an imaginary or a complex number. Therefore, when delta is less than 0, I don't get real roots. I get roots are complex or imaginary. Now, when delta is less than 0, the roots are complex or imaginary. So these are the three cases which define the roots in being either real and distinct, or real and equal, or complex or imaginary, with strictly with the definition of discriminant greater than 0, equal to 0, and less than 0, and discriminant connected with the root, square root of delta, which defines indirectly the three cases. So each of the cases have their own roots in its own nature. So hence, the significance of delta is to identify the nature of roots, decides the nature of roots. The three different cases as we are taken here. So let's take each of the cases with the three cases defined in the previous session with an example problems. So when I have the quadratic equation x squared plus x plus 7 equal to 0, then clearly I have a equal to 1, b equal to 1, c equal to 7, through which my delta is b square minus 4ac, that is 1 square minus 4ac, which gives me 1 minus 27, which is negative 27, and this is less than 0. Therefore, delta less than 0 implies the roots are, with the second case which says that the roots are real and complex, and the roots are complex or imaginary, is how we get the conclusion from delta. So we cannot have the real roots in case of delta being less than 0. We always get the complex roots where the root of a negative number includes in the root. So for example, I substitute in the formula minus b plus or minus this by 2a, then I have this minus b, which gives me minus 1 plus or minus root of this entirely being equal to delta, gives me the value as negative 27 by 2 times of a, which is 1. Thus, the root of a negative number cannot give a real value. Therefore, this whole of the two roots as obtained in case of this quadratic equation are said to be complex roots. The two complex roots being minus 1 plus root of negative 27 by 2 and minus 1 minus root of negative 27 by 2 are the two complex or imaginary roots identified in case of this. The case 3 of the discriminant significance. Next, let me take another example. Say x squared minus 5x plus 6 equal to 0. Then in this case, I identify a equal to 1 and b is minus 5 and c is 6. So here my delta is b squared minus 4ac, which on simplification gives me 25 minus 24 equal to 1. So my delta is 1, which is clearly greater than 0. Therefore, this comes under case 1 of the significance of delta. So delta greater than 0 implies the roots are real and unequal. They cannot be equal. So the roots are real and unequal. So delta greater than 0 implies the roots are real and unequal. Therefore, I have two unequal and distinct roots which are real. So when I want to find the roots using x equal to minus b plus or minus root of delta by 2 times of a, then this on using the formula reduces to the roots 5 plus or minus 1 by 2, which gives me two roots, one given by plus and 5 minus 1 by 2, which on further simplification gives me 6 by 2, which is 3, and 4 by 2, which is 2. Therefore, these two are real roots and are distinct. They are not equal, thus giving me the case 1 of the significance of delta, giving me the two real and distinct roots because delta is simplified to be greater than 0. So in this case, delta is simplified to be less than 0. So I get two real complex or imaginary roots. Here, two real and distinct roots for greater than 0. Now let's see the case 2 of the significance of delta, where I take the quadratic equation x squared minus 4x plus 4 equal to 0. So in this case, my a is 1, b is minus 4, and c is 4. Therefore, my delta is b squared minus 4ac, that is 4 squared minus 4ac, which on simplification gives me 16. So therefore, this gives me 16 minus 16, thus delta equal to 0. Now we all know that this is case 2 of the significance of delta, where delta equal to 0 implies the roots are real and equal. That implies when I have delta simplified to be 0, I get one repeated root when I solve this using the formula. So delta equal to 0 implies the roots are real and equal. That is, when I simplify this using the formula minus b plus or minus root of b squared minus 4ac by 2 times of a, then this on simplification gives me minus of minus 4 is 4 plus or minus 16 minus 16, by 2. Therefore, this would be 16 minus 16 is root 0 is again 0 by 2. This gives me 2 roots, 4 by 2 and 4 by 2 is 2. Therefore, I get one repeated root, which is 2. The roots of this would be 2 comma 2 with this value being repeated again, the case 2 of the significance of delta, thus leading to delta equal to 0 with 2 repeated roots.